Okay, so in the previous tutorial we have added this feature to actually extract the data relevant to any overrides from the data table, and currently we have that set up. Now let's see how we can actually use those stuff at the anim graph level, right? But first, in order to have that feature, I think it's better to have sort of a separated anim instance to handle those overrides, because then later on actually by using linked anim graphs we can easily plug those stuff to this specific anim instance, which is AVP locomotion, right? So our code base will be much more organized. Otherwise all the overriding stuffs will be existing here as well, right? So first I'll go to this folder, which is characters animation, and there let's create a new folder, and I'll call it as maybe anim blueprints, right? Here let's create a new animation blueprint based on schematica, right? I'll call it as ABP anim overrides. Okay, and no, maybe we can give it a better name. Maybe let's say layered blends, because inside this animation graph I'm going to handle all of those layer blends relevant to anim overrides. Right, let's open that out. Now I'll close the unused ones. Okay, and here we need few variables. So if you look at our data structure that is dedicated for anim sequence overrides, so we have this start position, override weight, interrupt speed, blend time, and blend type. So let's set override weight and interrupt speed. So I'll add a new variable called weight, which is float, and interrupt speed, which is again a float. Plus we need blend type as well, which is the type of anim blend. Okay, and then let's override the function for blueprint thread safe update animation, right? And here since we have the delta time, by using the weight, let's f interp to this as a target for a specific current, but first let's promote this to a variable, and I'll call it as blend weight, and maybe let's organize this stuff to a category so we won't get lost in our variable conventions. And this weight should go to this target value, which means the current should be this one and the target should be this one. Delta time should be plugged as here, and the interrupt speed is the provided interrupt speed as a variable, right? And by default I'll give the interrupt speed as 10, and yeah, that'll work. Okay, then let's go to the anim graph level, and instead of directly plug into here, let's first hit an input pause, right? So if you click the anim graph, you can add an inputs. So I'll add a first input and I'll call it as base pause. And then I'll add another input and let's call it as blend pause, the pause that I'm going to blend with, right? And instead of copying the pins like this here and there, let's just promote these two variables so we can easily use those cache pauses. So let's save it to cache pause, and I'll call this as base pause, and this one as blend pause. Okay, and then we can start with blendings, right? So here, like if you check the anim blend types, we have full body, upper body based on the layered blends bonds, and we have upper body mask and upper body lower body split mask based on the blend masks. So first let's start with these branch filter based blends. So I'll keep the output to here, and first let's use the base pause alongside the blend pause, and let's blend both like this. Okay, and as the alpha, let's give it the blend weight, and I'll save it and call this one as full body pause. Okay. And similar to that, let's get these three, and instead of blend, let's use layered blend per bond to have upper upper body blend, right? So here actually we have to specify the blend type as branch filter, which is fine, and as the layer setup, you have to specify what are the bonds that we refer. So I'll add a new branch filter, and we can add a blend at pelvis, maybe at the blend depth I'll add 5, and then thigh R, which is -1, and thigh L. So basically this means this -1s means to ignore these branches, or ignore these skeletons, right? So this one means basically apply the blendings based on this branch onwards, or based on this bone onwards, which is pelvis. So the upper body will be manipulated accordingly. And let's save this one as well. And I'll call it as upper body pose. Okay. So these are the basically branch filter based blend modes. So I'll comment this one as blend mode branch filters. And similarly, let's blend from blend masks as well. Right. So if I check the enumeration, we have upper body mask and upper body, lower body split mask. How can I do that? So I'll copy these three things and paste it here. And let's use layered blend per bond. But here, instead of the branch filter, let's use blend mask. And the blend mask should be upper body mask. And let's apply the mesh space rotations, and rest of the stuff we can keep as it is. And this is the blend pose, and this is the blend weight. And let's promote this, or let's save it to a cache pose, and I'll call it as upper body mask pose. Okay. And similar to that, let's copy these three things together, and as the blend mask, let's use upper body lower body split mask, and I'll save it to a cache pose called upper body lower body split mask pose. Right. So these are following the blend mode blend mask. Right. So we have these four types of blendings. We have two of the branch filters, and we have two from blend mask. Right. And then finally we can plug the output. So I'll move the inputs here. Let's organize output here. Okay, so in order to blend in between multiple different blend types, let's use this blend type enumeration, and let's call for blend poses and in blend type. Right. And let's add the required pins. So let's add, so the default is there, and let's add none, and full body, and upper body mask, and upper body lower body split mask. Right. And I think we need a blend time as well, otherwise we can't actually manipulate these variables. So I'll give it a variable called blend time, which is the type of float, and assign it to the setup category. And by default I will give it like 0.25, and we can plug the same blend time for each blend type at here. And then we have to properly plug these values. So for the default pause and the none pause, I can simply use the base pause cache. It is as exact same as it is, like this. And as the full body pause, we can use the full body pause cache, and upper body pause we can use upper body pause cache, and upper body mask we can use upper body mask pause. And finally, as the upper body lower body split mask, we can use upper body lower body split mask pause. Right. I think this would be okay. And finally, we can plug the output pause to here. So the final blended one will be written from there. Right. Yeah, and I think that's it for the anim instance. Right. And next what we have to do is simply plug this anim instance to our ABP locomotion and override the forward starting animations at proper places. So let's cover those stuff at the next part, and I think this would be a good place to stop the part 3. Sorry, actually it's part 4. Yeah. Yeah, so if I recap what we have been done, we just simply created a new anim instance called ABP layered blends, and then I created these 4 variables because later on actually we are going to plug this ABP layered blend inside the ABP locomotion. So we should have sort of configurable parameters. Therefore, I use these 4 as configurable parameters and assign it to a category called setup. And I'm overriding blueprint thread safe update animation function, and I interpolate and find this blend weight at here. And then at the anim graph, we have these 2 cache pauses, and these 2 will be used as reference process to blend 2 different animations. So we have 2 types actually. We have branch filter based blend modes, and we have blend mask based blend mode. So those stuff actually referred at here at anim blend type enumeration. So we have 2 types of branch filter based blend modes like this, and we have 2 types of blend mask based blend modes like this. And finally, based on the blend types that we require, we select and blend with the required pose and return it as the output pose. Right, so that's what we have been covered at the part 4. I'll see you there in the next one. Thank you.